All right, so we have one salt solution here, right? And a second salt solution there. So those are my two. I have my first salt solution. So we'll say salt solution 1. And then we have salt solution 2. All right, we'll change that to be color coded correctly. All right, so how much of the first salt solution do I have? How much? How many gallons of the first one do I have? 10 gallons, so I'm gonna put that there. How many gallons of the second one do I have? 8, right? All right, and then I have a percentage salt, right? How much percent is it salt? So how much percent is the first one salt? 12%. And how much is the second one? 80%. All right. They're mixing it together. And so for this one, it's a little bit tricky because they actually didn't tell us anything about the final solution, right? However, we know we mixed 10 and 8 gallons. So how many gallons is our final solution? What do I do with those? 18. Right, we add them. Remember this next column, I said you never add. We never add that column, right? So we're going to put an X there. We do not know how much that one is. We never add the percent column, ever. Okay? Because it's two different mixtures, so my final is not going to be 22%. It's actually going to be a combination of the 12 and the 80. Okay? It's not going to be like 92%. All right? So I'm going to multiply across, right? So if I'm trying to find how much salt is over here, I need to multiply across. 10 times 12%, right? So I'm going to say this is going to be 10 times 0.12, which gives me what? 1.2. Right, 1.2. And this is going to be 8 times 0.8, which gives me what? 6.4. Yep. And so here I can add down, right? So 1.2 and 6.4, what's my salt in my? Yeah, 7.6. What do I know about this bottom one? Multiply across, right? 18 times X should equal 7.6, right? So 18X equals 7.6. So far, so good? So how do I solve this one? Yes, always multiply across. So I'm going to divide by 18, which is going to give me approximately 0.42, and it's going to keep going. So what did I solve for? What was my X? 0.42, but what was that? The percent. So how do I change that to percent? So I'm going to move this over. So my final solution is going to be 42% salt, right? That is the percent. That's what they ask for right here, right? What percent of the final solution? So I answered that question, right? It says, how much of the final solution do I have? I actually solved for that a long time ago, didn't I? Yeah. How much? Well, I have 18 gallons. Well, then how much of it is salt? Well, I answered that too, didn't I? Right here, 7.6, right? 7.6 salt. All right, so for this one, he has 3 gallons of a solution that is 30% antifreeze. And so the solution is my first piece of this. And we are going to say this is gallons here. And then percent, that is antifreeze. And this is going to be gallons of antifreeze here. So for the solution, it is 30% antifreeze, and he has 3 gallons of it. So I have 3 gallons, that is 30% antifreeze. The next thing that we have here is pure antifreeze. And so this is going to be pure antifreeze. And it says how much. So that automatically tells us that's where that X is going to go. What percent of pure antifreeze is the what percent of antifreeze is pure antifreeze? 100%. So we're just going to say 100% there. All right. To get the first part of this column here, we're just going to multiply across, right? 3 times 30%, or 3 times 0.3. What's that going to give us? 0.9. And then we multiply across here, we just have x times 100%, which is just x, right? This last column is my mix. So I'm just going to add down here. This is going to be 3 plus x, right? For the mix, they actually tell us what they want as far as the final solution. They want it to be 65% antifreeze. So that's actually going to go on my percentage, 65%. And so over here, I'm going to have my 0.65 times my 3 plus x. And those are going to equal. So I will have 0.65, 3 plus x equals 0.9 plus x. And then we're just going to solve this. Distribute here, right? What's 0.65 times 3? Hopefully 1.95. Plus 0.65 times x is just 0.65x. 0.9 plus x. Move your variables to one side, your numbers to the other. So I'm actually going to move it over here so I don't have to deal with negatives. It's going to cancel. 1 minus 0.65 is what? 0.35. All right, then I'm going to subtract my 0.9. That's 1.05. And what's my final step here? Divide by 0.35. That's going to give me 3. And so I double check and make sure that I'm answering the question. My x was what? In this whole setup, what is my x?
The amount of pure solution.
Yeah, gallons of pure antifreeze there. And so x is going to be 3 gallons of pure antifreeze. And then we double check, is that what they asked for? Well, yeah, they said, how much pure antifreeze? And so this is my answer here. All right, so for this one, a nurse wants 4 liters of 5% iodine. She has 3 liters of a 3% iodine. What percentage of iodine should be added? All right, so the 2 pieces that I actually have here is what she already has, 3% of the iodine solution. And she is adding iodine. And so my first one is going to be my iodine solution. And the second piece of this is going to be my iodine itself. And again, this is liters, so we're going to say liters of that percentage of iodine, and then liters of iodine. And so for the solution piece of it, she has 3 liters, so that's 3 liters. It is 3%, so that is 3%. All right. We also know what she wants. All right, so the final mix here, she wants 4 liters. And she wants it to be 5%. So we have that row as well, what she wants. So then how much iodine are we going to add if she has 3 liters and she wants 4? 1. So this is going to be 1. What percentage of iodine is iodine? 100%. All right. 100%. In this case, however, what are they asking for? So is this pure iodine that they're adding? So if it were pure iodine, this would be correct, right? Did they say pure iodine? No. What did they actually say here? What percent iodine? All right, so this is actually what's going to go there. X is going to go there, right? And so when you're reading this, at first you're going to think, oh, they mean pure iodine, right? But what are they actually saying? This guy is actually a percent of iodine, all right? This is actually a percent of iodine. And so when you read it, unless they use the word pure, you can't assume it. Because in this case, they actually said this is a percentage of iodine. So for this one, we are going to multiply across just like we did before. All right, so for the first one, how do I calculate that? 3 times, how do I change the 3% to a percentage? 0.03, right? And so what is this guy going to be? 0.09. You need both of those, 0.09. All right, what about the next one? How do I calculate this one? Yeah, it's just going to be 1 liter times X, which is just going to give me X. And what about that last one? It's going to be 4 times 0.05, right? So what's that's going to be? 0.20, right? Or just 0.2. And then what's my final step here? These add up, right? So I have 0.09 plus X equals 0.2, all right? Equals 0.2. And how am I going to do this? Subtract, right? I need to make sure that I line up my zeros here, line up my decimals. So what's 0.20 minus 0.09? Yeah, 0.11. They want it in percentage. Am I in percentage yet? No. 11%. If my X is 11%, that is the mixture of iodine she's going to add. 11% iodine mixture that she's going to add to that. So pay attention to these, because if they don't use the word pure, you can't assume it. They'll say pure water, they'll say pure alcohol, they'll say pure iodine if they're adding it, all right? So pay attention to where your question is. What percent is your question? And so you know that in one of these, in the percent category, is where you're going to have your variable. All right, so this one says Leah left the hospital and traveled south at an average speed of 60 kilometers per hour. Sometime later, Daniel left traveling in the opposite direction. I will say sometimes instead of saying the word opposite direction, they could say north. Okay, and so just pay attention to if they're telling you that it is an opposite direction. Average speed of 60 kilometers per hour. After Leah had traveled for 5 hours, they were 480 kilometers apart. How long did Daniel travel? All right, so the two people that we have here, we have Leah and we have Daniel. All right, and so remember for these, we have our two people set up. And we have that rate times your time equals your distance. Because this is opposite direction travel, the total distance is going to be the two distances added up. All right, that is my opposite direction travel. And so then we just fill in what we have. Leah's rate, well, she was going 60 miles an hour, or kilometers per hour rather. And we know that she traveled 5 hours. So we have her rate and her time. For Daniel, we also know he was going to 60 kilometers per hour. But for him, it just says sometime later. So we do not know his time. We do not know his time. It could say 2 hours later, and then we wouldn't know either one of them or something. But just pay attention to the relationship. Sometimes they give you a relationship between the two. To find Leah's distance, what do? Multiply across. And so what do we get there? 300. And to find Daniel's, we multiply across. What is his distance? 60x. What do we know about those two distances? Do they equal? What do we do with these? We don't set these equal for opposite. What do we do with them? We actually add them. Distance 1 plus distance 2 equals what? Total distance apart, which they give us in the problem, right? 480. Right? When it's opposite direction, you add the distances. It's the only one that you add, right? The opposite, and when they're going opposite or towards each other. Every other one, they are equal. The round trip is equal, or if it's like same direction, those are going to be equal as well. So how do I solve this? What do I do first? Subtract my 300. And I have 60x equals 180. My final step here is to, I'm going to divide. X equals 3 hours.
I forgot where I said.
Says Wilbur made a trip to town hall and back. That automatically tells me this is round trip. All right, town hall and back. That tells me this is a round trip. The trip there took 5 hours. The trip back took 3 hours. He averaged 20 kilometers faster on the return than on the outbound trip. What was Wilbur's average speed on the outbound trip? So he's going there and back. What do I know about these distances? They are the same. We still have our rate times our time equals our distance. For round trip, you're going to have a there and you're going to have a back. So on the way there, the trip there took 5 hours. That is my time. The trip back took 3 hours. That's my time there. He averaged 20 kilometers faster on the return trip than on the outbound trip. Do I know how fast he went going there? I do not know. So what do I put for his rate? Do I know how fast he went on the way back? I don't know, but I do know it was 20 miles per hour faster, kilometers per hour. So I'm going to say yes, x plus 20, right? And then my last column, I just multiply, right? So what is this distance on the way there? And what is this distance on the way back? Right, parentheses. And as I said up here, the distances for this equal. So 5x equals 3x plus 20. Distribute. Remember, when you have that, you have to put parentheses there. Variables to one side, numbers to the other. All right, 30. What did I solve for? Distance, rate, or time here? What was my x? Yep, rate. So this is kilometers per hour on the way there or back? There. All right. His average speed on the outbound trip, outbound is on the way there, right? Outbound versus return. So that is my answer. Now, if they had said what was his speed or mile, kilometers per hour on the way back, you would have had to add 20 to that. So pay attention to what it is asking for. All right? It does not always ask for where you put your variable. Make sure that wherever you put your variable is what it's asking for. And if not, use that to go back and solve what they are asking for. All right, number 9 says Pranav left the Science Museum and drove toward the Capitol at an average speed of 42 kilometers per hour. Sometime later, Heather left driving in the same direction, but at an average speed of 70 kilometers per hour. After driving for 3 hours, Heather caught up with Pranav. How long did Pranav drive before Heather caught up? So we have two people here, right? We have Pranav, and we have Heather. All right, and so that's what I'm going to set up for my chart. I'm going to set up my two names here. Now for this one, They leave the Science Museum. They drive towards the Capitol, and at some point, Heather catches up. So what do I know about these two distances? They're the same. All right? They are the same. All right. So, do I know the rate for the first person? What is it? 42 kilometers per hour. Do I know the rate of the second person? Yes. What is that? 70. All right. Do I know the time of the first person? No. What am I going to put there? Or T, yes, whichever, but I usually use variables that I can see. All right. Do I know the time of the second person?
X plus 3.
So if it said she left 3 hours later, then that would be X minus 3. All right. Or she left 3 hours earlier, that would be X plus 3. So you're looking for a later, earlier if you're going to do an add or subtract here, which you possibly could do. In this case, they straight up said after driving this many hours. Okay. So this is just going to be 3. It's just going to be 3. All right. So how do I find my distance for the first person? Yeah, 42x. Distance for the second person? 210, right? All right, so I have 42 miles an hour for the first guy. Time we don't know. Heather left sometime later, driving 70 miles, and she drove for 3 hours. All right. So then I'm going to say these two equal. 42x equals 210. All right. What's my final step here? Divide by 42. All right. What is 210 divided by 42? It's just 5. 5 hours. All right, 5 hours. What does that tell me? 5 hours what? Is how long who drove? Right. Is that what I was asking for? Yes, so that is my answer. All right, it says vegetable oil, which costs $3 a kilogram, is made by combining soybean oil, which is $1 per kilogram, with canola oil, which is $4 per kilogram. Find the number of kilograms of soybean oil and canola oil required to make 21 kilograms of vegetable oil. All right. So the two actual things that we have here are soybean and canola. All right, so the soybean oil is our first one. The canola is our second one. And the vegetable oil is our blend. So the vegetable oil here represents our mixture. For this one, we are talking about kilograms. We are talking about a price per kilogram and then the total price here. So soybean cost $1 per kilogram. So that's what we're going to put right here. Canola cost $4 per kilogram. And our vegetable cost $3 per kilogram. So we know all of our dollar amounts here. All right. We also know the total of the vegetable oil, which is 21. We do not know the two other ones. So if we have X amount of soybean, how much canola are we going to have? So 21 minus X. So flip it this way, right? 21 minus X. The total that we have minus what we already have is going to be what's left over. And just like everything else we multiply across, X times 1 is X. 4 times the 21 minus X. And then for the vegetable, we actually just multiply those. So 21 times 3 is going to give us 63 there. We also know that this last category adds down. So we have x plus 4 times 21 minus x equals 63. And to solve, we're going to do what we have always done to solve. Distribute, combine like terms. Variables to one side, numbers to the other, and divide. So we have x, distribute that 4. 84 minus 4x equals 63. Combine my like terms, x and negative 4x gives me negative 3x. Subtract over. Negative 3x equals, I did that backwards too, so it's okay. Negative 27, is that right? Did I do that right? No, negative, 21, is that what? No, it's not negative 21, is it? Should be,
How did you get negative 81 under 64?
hang on, I'm like, helps to write it down the same on both sides, by the way. All right, that'll make it a little bit easier. Divide by negative 3, x equals 7. What does that tell me? What does that 7 tell me? Tells me how much soybean. What did they ask for? They actually asked for both. So I would say, well, if they want both, I already know I'm going to have 7 kilograms of soybean. How do I find the canola? Subtract.